Hello sir, so today I'll be talking about the mini project tree which we are required to construct a casino type game. So first of all, these are all the modules we needed to use in this mini project tree. So before I move on to the demonstration video, I would like to show the pseudo random number generator which I name it as RNG generator. So as we can see here, these are the seed values which will produce different random sequence of number. So the table of the sequence of number and the seed values can be found in the report here, and these are the different output sequence generated by different seed values. So currently I will be selected the 0, 1 as my seed values because it has the most balanced win and lose rate. So before I run the game, I would like to briefly explain about the casino type game. So this one, the first one, red LED 9 represent the system has been resetted, and this one, the last red LED 0 represent the lose operation. This one, the first green LED 7 represent the win operation, and this one, the last green LED represent the try again operation. So whenever I push the let's say the system is running, whenever I push the reset button, so the system will be resetted. Yeah, this one is the reset button, and this one, the SW2, is the roll button. So when this button is being pushed, the system will generate random number. So if the players wants to win the game, it has to roll the number of 7 and 11 in order to win the game. So if the players rolls the number of 7 and 11, this one, the first LED G will light up, which means it's a win operation. So if the players lose the game, it has to roll the number of 5, 8 and 13. So if the players rolls that 3 numbers, this one, the last one, red LED 0 will be light up. So if the players the players rolls the value which is out of that 5 specific values, so this one, the last one, green LED will light up, which means it's a try again operation. So when this one is light up, the player has to reroll this button again, so that to determine whether it is a win operation or a lose operation. So the first row value will be stored in the point register first, and then wait for the second row value, and these two value will be compared whether it's same or not. If the value is the same, so the players win. So if the values is not the same, the player lose the game. So let's say if the players at the first row he rolls maybe 4, and the second row he roll 4 also, so the players will win the game. And if the players for the first row he rolls 4 and the second row he roll maybe 5, the player will lose the game. So before I try the game, I would like to say also about these 277 LEDs. So currently the system is under reset condition. So since what I said just now, I use the seed value of 0, 1. So this one, 0, 1 will be represent the seed value that I use that I use. Yeah, so this one, the seed value 0, 1 will be my initial seed to start the linear feedback shift register to start the random generator, random generator sequence of number. So when this one, the roll button is being pressed, it will generate two different 4-bit numbers each at these two sides. Yeah, so these two sides, the value of these two sides will be add up and then form an integer. So let's say I roll the button. So this one is 1 and this one is 0, so the addition of these two values will be the 1. So if I reroll another button, So this one is F and D. So F in binary is, in hexadecimal is 15, and D in hexadecimal is 13. So 15 plus 13 is equals to 28. So we can see that the first row I roll 1 and the second row I roll 28. So the first one is not equal to the second one, and 1 is not equal to 28. So it is a loose operation. Yeah, loose operation. So now I will reset the system again. Yeah, it will back to the original seed value. So I want to try the first ring operation and the first loose operation. This one is try again. Yeah, this one is the first loose operation because 8 plus this one 8 plus 5 is equals to 30, is equal to 13. So what I said just now, if the players first roll 5, 8 and 13, the player will lose. So this one 5 plus 8 is equals to 13, and the loose LED will light up. Yeah, so now I will reset the button again, and I will try for the first ring operation. Yeah, so this one, the B in hexadecimal is 11. So what I say just now, if the player rolls the value of 7 and 11, so the first LD green 7 will light up, which means it is a wing operation. So I just tried the first row wing operation and first row loose operation and second row loose operation already. So now I will try for the last operation, which is second row wing operation. So I will reset the system first. Yeah, finally, I was so unlucky. Yeah, so as we can see that the first row the value for the first row is 0, 2. So 0 plus 2 is equals to 2, and this one the value is the second row. So this one 2 plus 0 is equals to 2 also. So the players win the game. Yeah, so to win the second row game, the players for the first row has the value for the first player rows has to be equals to the second value that the player rolls. Yeah, so that's all for my demonstration video. Thank you.